The United Kingdom is an island nation, famous for its mild, damp winters. Our winters are usually cool and wet, with temperatures just above freezing. The Gulf Stream, a warm Atlantic current, keeps our climate gentle compared to places like Canada or Russia at similar latitudes. Even a dip to -5 degrees Celsius can cause major disruption here. Truly severe cold, -30 degrees, feels unimaginable. Yet our weather is part of a global system, and distant events can have dramatic local effects. The question is, could something override the Atlantic's warming influence? To answer that, we must look north, to the frigid air mass atop our planet in winter. Our infrastructure is built for mild winters, not for Arctic extremes. A true deep freeze would test our resilience in ways unseen for generations. It's not about alarm, but understanding. Could the UK ever face a winter unlike any in living memory? Let's explore how such a scenario could unfold. The story begins far above us, in the swirling cold of the Arctic. High above the Arctic, the polar vortex spins, a fortress of the coldest air on Earth. It forms each autumn as the North Pole plunges into darkness, locking frigid air in place. When the vortex is strong, it keeps the cold contained and the UK enjoys mild Atlantic-fed winters. But sometimes, the vortex wobbles or splits, like a spinning top losing balance. When this happens, the fortress walls crumble, and lobes of Arctic air can escape south. The jet stream below, usually straight, becomes wavy and erratic. This allows cold air to plunge south and warm air to surge north. For the UK, a disrupted vortex means the door opens to truly cold air from the continent. The key to a historic cold spell lies in this upper atmosphere drama. When the vortex weakens, the UK's mild winter shield can fail. The result? A sudden, severe chill that can grip the nation. Understanding the polar vortex is crucial to predicting our coldest winters. The next step: how does this icy air actually reach us? It's all about a chain reaction in the atmosphere. The most dramatic polar vortex disruptions are triggered by sudden stratospheric warming events, or SSWs. These events rapidly heat the stratosphere above the Arctic, weakening or splitting the vortex. When this happens, the usual westerly winds over the UK can reverse, bringing in air from the east. To our east lies Siberia, source of some of the coldest air on Earth. This is how the infamous beast from the east arrives, a direct pipeline of frigid, dry air sweeping across Europe to Britain. The effects aren't instant. It can take a week or two for the changes to reach the surface. Meteorologists watch SSWs closely. They're a warning that our weather is about to shift. When the jet stream buckles, the gates to the Arctic's deep freeze can swing open. The UK's mild winter can be replaced by a harsh continental chill. This is the atmospheric domino effect that sets the stage for extreme cold. -30 degrees may sound impossible, but the UK has come close. The coldest recorded temperature, -27.2 Celsius, occurred twice in the Scottish Highlands. These records were set in Braemar, 1895, and Altnahara, 1995, during periods of exceptional cold. Both times, high pressure brought calm, clear nights and drew in bitter continental air. Deep snow cover reflected sunlight, preventing daytime warming. Even England and Wales have seen temperatures below -20 degrees. The winter of 1981 to 82 and the legendary 1962 to 63 saw Siberian air flood west for weeks. These events prove the UK's climate can produce severe cold when the right ingredients align. A drop to -30 isn't physically impossible, just exceptionally rare. It takes a perfect combination: disrupted vortex, continental air, clear skies, and deep snow. History shows we've come close before. The question is, could we go even further? Let's look at a modern example. The Beast from the East in 2018 is the UK's most vivid recent memory of a polar vortex disruption. Weeks after a sudden stratospheric warming, the jet stream buckled and Siberian air swept in. Temperatures struggled above freezing, and wind chill made it feel even colder. Fine, powdery snow drifted across the country, blocking roads and isolating communities. The nation ground to a halt. Transport, schools, and the NHS all strained. This wasn't just a historical oddity, it was a real-time demonstration of our vulnerability. While rural spots dropped to -14, it didn't break records, but it was a textbook case. SSW, wind reversal, Siberian air, and widespread disruption. The Beast showed how quickly our mild climate can be overridden. It was a warning shot, a glimpse of what's possible if the atmospheric dominoes fall just right. Could it be even worse? Science suggests yes, but with a twist. Let's explore the paradox of cold in a warming world. The story isn't as simple as it seems. How can extreme cold happen in a warming world? The Arctic is heating up twice as fast as the rest of the planet, a process called Arctic amplification. As sea ice melts, dark ocean absorbs more heat, further warming the region. This reduces the temperature difference between the pole and the tropics, weakening the jet stream and polar vortex. A weaker, wobblier vortex is more easily disrupted, making SSWs and cold snaps more likely. Paradoxically, climate change could mean fewer average frosts, but more volatile winters with sudden severe cold spells. The Beast from the East could become less rare, even as overall winters get milder. Melting Arctic ice may open the door to more frequent deep freezes. The climate system is full of such surprising connections. Understanding them is key to preparing for the unexpected. Sudden stratospheric warmings, or SSWs, are the engine behind many cold snaps. They occur high in the stratosphere, triggered by atmospheric waves, often from mountains or land-sea contrasts. When these waves break, they rapidly heat the polar stratosphere, disrupting the vortex. The winds can even reverse, shattering the stable vortex and freeing Arctic air. About 2/3 of SSWs are followed by significant cold spells in Europe or Asia. Predicting exactly where the cold will go is a major challenge. SSWs happen roughly 6 times per decade, and their frequency may be rising as the Arctic warms. The 2018 Beast from the East was preceded by a dramatic SSW. Understanding these events is crucial for forecasting future winter extremes. For the UK to hit -30 degrees, a perfect storm must occur. It would start with a powerful, prolonged SSW, splitting the vortex and parking frigid air over Scandinavia. A deep, persistent easterly would draw air from Siberia, crossing a frozen Europe with minimal warming. The air would need to reach the UK almost unmodified, arriving at perhaps -20 degrees. Locally, a high-altitude Scottish valley with deep snow and clear, calm nights would allow maximum cooling. Only with all these rare factors aligned could the record be broken. Such an event might happen once in centuries, an atmospheric lottery win no one wants. It's the ultimate worst-case scenario for a UK winter. Could the UK ever freeze at -30 degrees? The answer: yes, but it's extremely unlikely. We've come close before and the mechanisms are understood, but the chain of events required is so rare that it would be a true statistical outlier. Even with a major vortex disruption, the Atlantic's influence usually prevails. Climate change adds complexity, warmer winters overall, but perhaps more volatility. The Beast from the East was a warning. The connection between a disturbed vortex and UK weather is real. We shouldn't fear a -30 winter, but we should understand it's possible. It reminds us of our vulnerability and the power of the climate system. The UK is a nation of mild winters, but not immune to the Arctic's reach. Preparedness and understanding are our best defenses against the unexpected.